Hello guys! Welcome back to another math tutorial! A vertical cylinder having a circular base of radius r and a height of 10 meter is filled with water at the rate of 1 meter cube per minute. How long will it take to fill the cylinder? Second, if the depth of water in the cylinder at the vertical position is 4 meter, what is the maximum depth of water the cylinder is in a horizontal position? Now, here, how long will it take? So, solution, first we have to, for the first one, how long will it take? So, the time, the formula for the time is equal to the volume over the discharge. Now, volume, of course, of a vertical cylinder is equal to pi r squared H. So, if T is equal to the time is equal to the volume over the discharge. The discharge is the rate of change of volume with respect to the time. So, 1 meter cube per minute, that is the discharge. Therefore, we can substitute, while the volume of the cylinder, the formula is equal to pi r squared H over the discharge, which is equal to 1 meter. Therefore, substituting the value of H, which is equal to 10, over 1. Therefore, it's equal to 10 pi r squared. So, yun ang sagot natin sa first question. Then second, if the depth of water in the cylinder at the vertical position is 4 meters, what is the maximum depth of the water if the cylinder is in horizontal position? So if it is in the vertical position, the depth, so there is the height of the water, which is equal to 4, and this is the R. Therefore, from this you can find the volume of the water, which is equal to pi r squared H, which is equal to pi r squared times 4, which is equal to 4 pi r squared. That is the volume. Now here, when this one naging nasa horizontal position, ang volume pa rin ng water is the same, which is 4 pi r squared. So here, kung nasa na siya, nasa horizontal position, so we have to make a rough sketch of the cross-section of the horizontal cylinder in a vertical position. So, halimbawa, ito ang center niya. Of course, the water is here. So, here is the center, and then the radius is from here to here. This is a radius. Radius is everywhere. It's the same. So, radius here. So we can have, so here we are, we're looking for the depth of the water of the cylinder. So if this height is the radius from here, if this is the radius, and this one from here to here as the depth, this is where we're looking. Of course, this one can be solved by using the trigonometric function, which is equal to cosine of theta, which is equal to the adjacent over the opposite. Now, adjacent over the opposite, which is equal to the r cosine theta. Yan ang length nitong side na to, r cosine theta. So to solve this depth of water, if the cylinder is in the horizontal position, first we have to solve the area. This area, sector of a circle plus this area. So this one is A1 and this one we call it A2. So A1 therefore, wait, from this diagram, if this is the, therefore this one is equal to r cosine theta. By using trigonometric function, cosine theta is equal to this adjacent over the radius. Therefore, it is equal to r cosine theta. And the other side, this one is equal to r sine theta. Also using the trigonometric function, which is the sine. So sine theta is equal to this side over this r. So therefore, r sine theta. Now, we can solve now the area. Area 1 is equal to the area of the spherical sector. So the area of the spherical sector is equal to pi r squared theta over 180. So this is, we have this area 1. Now to solve the area 2, from this triangle, area 2 is equal to 1/2 the base. What is the base? This is the base, which is equal to twice r sine theta. Twice kasi r sine theta plus r sine theta is equal to 2 sine theta. Times, multiply by the height which is equal to r cosine theta. This is the area of the triangle, so that is our area 2. Therefore, we can solve the area, net area, which is equal to the area 1 minus the area 2, which is equal to the area 1, which is pi r squared theta over 180, pi r squared theta over 180 minus A2, which is equal to 1/2 2r sine theta cosine theta. R squared, of course, because r and r. Pi r squared theta over 180 minus, of course you can cancel these two, so r squared sine theta cosine theta. This is the area. Therefore, the volume of this one, the volume of this water is equal to the area, which is equal to this one, the area times the length, which is equal to 10. Because ito, ang height nito is 10. Ngayon, pag mabaliktad, pag maging horizontal yan, ganun pa rin ang length niya is 10 pa rin. Ang height naging length, so is 10. Volume of this one will become 10. Substituting this one to this one, this is the volume. Now here, we have to substitute the value, which is equal to, since the volume is the same as the one during the vertical position, so we can substitute V as 4 pi r squared. 4 pi r squared is equal to the area, which is equal to pi r squared theta over 180 minus r sine theta cosine theta. So here, because both sides have r squared, so we can cancel r squared, r squared, r squared. 4 pi therefore is equal to pi theta over 180 minus sine theta cosine theta. Simplify this one. This one, it will become 1.256, which is equal to this pi theta over 180 minus sine theta cosine theta. Now this one, to find the theta, we have to use trial and error method. So assuming that if theta is equal to 80.8, therefore we can substitute the theta here, the value of theta. Therefore it's equal to, after substituting the value, it will become 1.256 on this side, and then computing this one using the 80.8 degrees is equal to 1.252, which is almost the same. So, pwede na yan. Ang theta, pwede na yan maging 80.8 degrees. So now, because we have already the theta, we can solve already the d, which is this one, distance from here to here, which is equal to r minus this distance, this one from here, which is equal to r cosine theta. Therefore, substituting the value of cosine theta, which is equal to 80.8, d therefore is equal to 0.84 r in meter. So yun yung answer natin, the maximum depth of water if the cylinder is in horizontal position.